Solution of linear system of equations by elimination method. Here we are given a system of linear equations in two variables and two equations. We will use elimination strategy to solve this system of equations. Let's get started and name the equation 1 as equation 1 and equation 2 as equation number 2. We will use a procedure in two steps. In step 1, that's what we are going to do. Here we will identify the coefficients of x for both equation 1 as well as equation 2. So coefficient of x, that is 2, and here in the second equation, coefficient of x, that is equal to 4. So what we are going to do, we will multiply. Let's write down the both equations in front of these coefficients. Here, this equation where we got the coefficient of x is 2x plus 3y equal to 6, and the second equation is 4x minus 5y equal to 8. Our objective is to make the coefficient of x same, including the signs. The easiest way to do that is if we multiply the coefficient of x in first equation with equation number 2 and the coefficient of x in equation number 2 with equation number 1. So what we are going to do here, we will be multiplying equation 2 with 2 here and equation 1 with 4. Obviously 4 will come here. Let's rename the system same way as equation 1 and equation 2, because we have multiplied a constant number on both sides of the equation. That doesn't change anything. So therefore we have a new system which is 8x from equation 1. 8x plus 12y is equal to 24. And the second equation will become 8x minus 10y is equal to 16. So this is equation 1 and equation 2. So we can continue. If we want to name it, we can continue to keep its name same. And now we are going to subtract, and for subtraction what happens is we change the signs of second equation. Subtraction, and for subtraction what we are going to do here is we'll change the sign here, change the sign here, and change the sign here. So this is, we cancel x, 8x, take away 8x will be gone, and 12y minus and has been changed to plus. So 12 plus 10 will become 22y equal to 24 minus 16 is equal to 8. And dividing both sides by 22 now, this implies 22y divided by 22 equal to 8. That must be divided by 22 as well. Therefore we have y equal to 8 over 22, which can be further simplified by 8 divided by 2 and 22 divided by 2. If you divide the numerator and denominator by the same number, that doesn't change. It's just an equivalent fraction. So y therefore in simplest form will become 4 over 11. We are not going to substitute because we are using an elimination strategy. Therefore, what we have done for coefficient of x, we will do the same thing for coefficients of y now. So let's rewrite those equations, but this time we are going to write coefficients of y. Coefficients of y in equation 1 and coefficient of y in equation 2 and in equation 1. So what is coefficient of y here? For the second equation and for the first equation, the coefficient for the first equation is plus 3. Therefore, we write just 3. And for the y, it is minus 5. That is minus 5. Let's write down the equations here. The first equation is 2x plus 3y equal to 6. 2x plus 3y equal to 6. And the second equation is similarly 4x minus 5y. 4x minus 5y equal to 8. So let's just confirm 4x minus 5y equal to 8. So these are the equations, and just the way we did cross multiplication for eliminating x, we will multiply the same way with the coefficient of y in equation 2 with equation number 1 and coefficient of y in equation 1 with equation number 2. So that's what will help us to eliminate y this time. So here it will be minus 5 that will be multiplied, and here it will be 3 which will be multiplied. Let's perform these multiplications and rewrite those equations. This will become minus 10x minus 15y minus 15y equal to minus 30. So that is equation number 1 now, and the second equation will become plus 12x. So this is 12x and minus 15y minus 15y equal to 24. So like right from the start, our intention was to make the coefficients of y same, which we have minus 15 for equation 1 and minus 15 for equation number 2. So this is still equation 1 and this is still equation number 2. In order to eliminate y, we are going to change the signs. So again we do subtraction, and for subtraction we are going to change the signs here. For equation number 2, this will become minus, this will become plus, this will become minus again. This time 15y will be gone with 15y, and what we will have is minus 22 minus 22x equal to minus 54. Minus 54, and now we are going to divide minus 22 on both sides so that we can get the value for x. Minus 22x divided by minus 22 is equal to minus 54 divided by minus 22, and what this will give us is x equal to 54 over 22. Obviously it is not in simplified form. We can divide this by 2, divide this by 2, so that we can get the value of x in lowest form, and that value of x we have got is 27 over 11. So this is value for x. We already have got the value for y. So that's what we have got is the solution of the given system of equations. X and y is 4 over 11. If we need to verify this solution, let's do the verification process. Verification, and we know that we write the point here. What is the point? That is x and y, 27 over 11, and y was 4 over 11. So let's see if this point is point of both lines. For that purpose, we are going to divide our workspace here and write the point for both 27 over 11. For second equation as well, 4 over 11. And now let's write down the first equation, which is 2x plus 3y equal to 6. 2x plus 3y equal to 6. And the second equation is 4x minus 5y. 4x minus 5y equal to 8. Now, if this point is part of both lines, it must satisfy both of the equations. So therefore, 2 times x is 27 over 11 plus 3 times 4 over 11 equal to 6. And if that is the case, this should become 54 over 11 plus 12 over 11 equal to 6. On the left hand side, the LCM is same, that is 11. Therefore, we are going to add just the numerators because the denominator is same. 54 plus 12 over 11 equal to 6, and what we have here is this is 66 over 11 equal to 6, and that gives us 6 equal to 6, which is true, which is a true sentence, and it must be true for the second line as well. For second, we have 4 times 27 over 11 minus 5 times 4 over 11 equal to 8. And if that is true, then 4 times 27 is equal to 108. That is 108 over 11 minus 20 over 11 equal to 8, and this will give us 88 over 11 equal to 8. And here what we have is 8 equal to 8. So this is also verified. It means that the point 27 over 11 and 4 over 11, this point here, P, that is common point of both lines. So the lines intersect each other at 27 over 11 and 4 over 11. Therefore, we have successfully used elimination strategy to find the crossing point of both lines.